In this video, we're going to look at writing absolute value application problems. We call these tolerance questions. The formula that we need is the absolute value of x minus the ideal amount is less than or equal to the tolerance. Keep in mind this should always be a minus between the x and the ideal amount, and it should always be set as less than or equal to the tolerance. So let's take a look at some examples. In the first example, it says most fish can adjust to a change in the water temperature of 15 degrees up to 58 degrees if the change is not sudden. Suppose a lake trout is living comfortably in water that is like in that range of temperature. I think there's a word missing there, but don't worry too much about that. Write an absolute value inequality and compound inequality that represents the range of temperatures at which the lake trout can survive. So they gave us a high and low temperature. So we can take that and write out the compound inequality first. So that just means that we have to write that the ideal or the actual temperature, which is our x, would be greater than or equal to the lowest amount, which is 15 degrees, and less than or equal to the higher temperature, which is 58 degrees. So that's our compound inequality. That's all they mean by that. And then they want us to write the absolute value inequality, which is what our formula represents. So we just need to do a little bit more work to get the ideal number and the tolerance from our compound inequality. So they gave us a low temperature and a high temperature. The ideal amount is the average of these two. So I'm going to write ideal equals average. So let's find the average. Let's say 15 plus 58 divided by 2, and I'm just going to use Desmos to calculate that. It works as a calculator when we need it to. So 73 divided by 2. All right, so we get the ideal amount. The ideal temperature is right smack dab in the middle of the lowest possible temperature and the highest possible temperature. That would be the temperature that's just right for the fish. So let's put x minus 36.5 in absolute value symbols. It's always less than or equal to the tolerance. So we just have to do a little work to figure out that tolerance, which would be how far is 15 degrees from 36.5, which should be the same amount that 36.5 is from 58. In other words, how far away are those extreme values from your ideal value? And you can just use some simple calculations to figure that out. So let's say 36.5 minus the lower number would be easy to type in. So 36.5 minus 15 gives us 21.5. So that's like the difference between the two. And then it's also the same amount between the ideal amount and the higher possible temperature for the fish. And I'm going to write that over here in the same color. And then we have our absolute value inequality, which was in blue and a little bit in red. And we wrote our compound inequality first, and we put that in purple. So that's the difference between those two things they asked for. All right, so let's take a look at number 2. A company that makes golf balls needs to ship bags of balls that contain at most 696 and at least 584 balls. Write an absolute value inequality and compound inequality to represent the range of golf balls that would be in a bag. So let's follow the same color scheme. Our compound inequality is what they've given you. You have the lower amount and the higher amount that's possible. So put x in the middle. X is like your actual amount. So x should be greater than or equal to the 584 and less than or equal to that bigger number, which is 696. So if you look back at our first example, we've got to find the ideal number of golf balls, which is the average of the two. So we already wrote that down. Let's just find the average of these two. So the ideal amount is 584 plus 696 divided by 2. And I'm going to clear out Desmos to type these numbers in for this question so that you don't get mixed up with the first one. 584 plus 696 is 1280. It's being kind of sensitive today. So 1280 divided by 2. I got 640, so that would be the ideal number of golf balls to send. So to write out our absolute value inequality, we put x minus that ideal amount, which we figured out was 640, is less than or equal to, and then we've got to figure out the tolerance. So the tolerance is how far away is that smallest amount from the ideal amount. So remember, this middle number here is ideal. And it should be the same amount from the ideal amount to your maximum number. So like the minimum number, the ideal amount, and the maximum number are equally spaced apart. So there's more than one way to figure it out, but I like to take the middle number and subtract the smaller number to get there. Okay, so 640 minus 584 is 56. So that is your tolerance. And it should be the same amount. So if you want to just double check your work, you could say 640 plus 56, and notice that that does give you 696. Then I'm going to write that up here in my formula. So I've got the absolute value of x minus 640 is less than or equal to 56. And I'm just going to do one last thing and underline the absolute value inequality, which we wrote out in blue and in red. Okay, let's look at two more examples. These are a little different in what they give you. So notice they could give you your compound inequality first, but they could also give you the absolute value inequality first, which is what they do in these last two examples. So your car averages 32 miles per gallon in the city. The actual mileage varies from the average by at most 5 miles per gallon. Write an absolute value inequality and a compound inequality that shows the range for the mileage your car gets. And so what they have given you here is the ideal amount is just stated in the problem. So ideal is 32 miles per gallon. And you don't really have to put the units for that. So let's go ahead and start writing x minus the ideal, which is 32, is less than or equal to, and then they gave you the tolerance because they said it varies by at most 5 miles per gallon. So that is your tolerance. That's how much it could be off by. It can vary. And then the other thing we need to write is our compound inequality. Let me highlight that, and then we'll find that out. So to find the compound inequality, a really simple thing to do is just take your ideal amount, which was 32, and add 5, and take 32 and subtract 5. And so you figure out the highest amount would be 37. That's your maximum possible number. And your minimum possible miles per gallon is 32 minus 5, which is 27. So to write your compound inequality, you would say that the actual miles per gallon is greater than or equal to 27 and less than or equal to 37. All right, so then you've got your absolute value inequality in blue and red, and your compound inequality is in purple. Let's do one last example for this lesson. A professional baseball should weigh 5.125 ounces with a tolerance of 0.125 ounces. Write and solve an absolute value inequality that describes the acceptable weights for a baseball. So they were really nice again and just gave you the information straightforward So a professional baseball should weigh 5.125. Well, that is the ideal amount. You can kind of notice from the language they use, that's ideal because it should weigh that amount. And then the tolerance, they even use that word, is 0.125 ounces. So let's go ahead and write our absolute value inequality. So x minus 5.125. So it's always subtracting. It's always less than or equal to the tolerance. So that is our absolute value inequality. To get the compound inequality, we just take that ideal amount and we add the tolerance, and then take that ideal amount again and subtract the tolerance, and you end up with your maximum and your minimum amount that would be allowable, that would be acceptable. So 5.125 0.125 plus 0.125. It's just taking me a minute to get it to accept the numbers today for some reason. Okay, so we got 5.25 is the maximum amount, and then let's put 5.125 minus 0.125, and we get 5. And so to write out the compound inequality, we've got to put x would be greater than or equal to 5 and less than or equal to 5.25. All right, so we've got our absolute value inequality and our compound inequality written out. We're all done with that one. So that's it for the examples for tolerance questions.